Afternoon, everyone. Thank you for joining today's knowledge on unleashing the power of type level programming in Scala. My name is Yash Gupta, and I'm senior software consultant in Nasdaq, and I'm really excited to explore this advanced topic with you. So let's dive in. So before anything else, let's first discuss some knowledge etiquette. So punctuality. Join the session 5 minutes prior to the session start time. We start on the time and conclude on the time. Feedback. Make sure to submit constructive feedback for all sessions as it is very helpful for presenter. Keep your mobile devices in silent mode. Feel free to move out of session in case you need to attend an urgent call, and avoid any disturbance, any unwanted chit chat during the session. So let's talk about today's agenda. Today's topic is type level programming in Scala. So first we talk about it and its highlights. Then we will move forward and we'll talk about the implicits. What are they and what's the importance in the type level programming. After that, we will talk about the type analysis. And in the last, I will show you introductory level demo. Okay. So let's get started. So what is type level programming? Let's start by defining the what is type level programming. The type level programming is powerful technique in Scala that allows developer to work with types at compile time. Uh, Unlike programming, where we manipulate values, type level programming deals with the type themselves. I will show you the demo of it, like full working demo, where we will deal with the type levels and the type aliases. So let's first see their highlights, what the components which is used in the type level programming and has their importance in it. Also, type level programming allows developer to catch error at the compile time, reducing the likelihood of bugs and making code more robust. So it also enables developer to create more like expressive APIs and write more concise and reusable code, right? So let's see some highlights of this type level programming. Compile. First one is compile time computation. This is one of the key feature of type level programming in compile time computation is compile time computation. So for instance, we can calculate values and properties at compile time, reducing the need for runtime calculation. So if I talk about more about it, there are some calculation that we do on the at the compile time that offers the benefits such as optimized code and early error detection. So if you see the example where I like try to explain what is compile time computation, uh, we have simple program that calculates the sum of two number one and number two. Uh, so if you see that when we compile this code, the number one will initialize with this five, and number two will initialize this seven. And this sum at the compile time, we will have the sum of this number one and number two. And the most important thing, whenever we use these variable, we will get the value that was initialized at the compile time. Yeah. Someone have any question? Okay. So keeping this compile time computation in our mind, let's move forward. Now, type level programming gives us the very fine grained type control. It involves enforcing precise constant on types to ensure the correctness and robustness. So if I talk about the type control, we can simply give the type whatever we want. Like we can give the type to the trait, we can give the type to the class, we can give the type to the method, we can give the type to the variables, and these type can be our self-made. And these type cannot be the predefined ones. We can also declare our types so that we can use them later and we can abstract our code more efficiently, right? So we can enforce this type constant using using this generic type aliases. This T thing, like if you see the example here, we have this container, trait container that has a generic type, right? And as you can see that here, if I want to process this container by using this process container method, I have to be the parameter should be the type of container int, right? So if you see the definition of the main method here in the val int container, we already we already initialize the object of container that has a type int, this int will go to this t, and this t will reflect on all the variable, all the family members of this trait. Like value will be the type of t, now it will be the type of integer. And when we will override this value, it will be the type of int and the value will be 10. And when we try to process this container, it will be always be. Now if we want to process it with other, like if we initialize a variable with the container of a string, right? If I replace this integer with string, this line will not be compiled, process container in int container, because in the method we have parameter of container of int, so we can't pass the container of string. So this is the fully type control, right? So this is the thing we can get in the type level programming, and we can get full control in the compilation time. And we can also find all the errors that can analyze at the time of compilation. Okay, so let's move forward. Now, what are implicits and what are the power of implicits? Implicits are a powerful feature in Scala that plays a significant role in type level programming. They allow us to enhance code readability and automate tasks like type conversion and resolutions. If I more talk about it, if I or what I can say that suppose you declared a method, and in that method you want a parameter or a value that automatically initialize in it, right? So at that place you can use implicit variables. So if I talk about this example, as you can see that here we have a object implicit example, and we have a method in this which is called apply discount, right? What it will do, it will simply apply the discount. Now suppose there is a scenario where you want a default discount value and you don't want to pass it every time. So there can be two ways. First one, you can pass it in the parameter. Now, if you pass in the default value in the parameter, the most of thing is when you are going to initialize the parameter values of the apply discount, you have to give the parameter name, because if you misplace the numbers of the parameter, it will give you the compile time error. So the second way is that you can use a implicit variable, right? Like here that I used here. So as you can see that here the apply discount method has an implicit value discount, right? So when we call this apply discount, what it will do, it will try to find out an implicit. Now you can pass an implicit automatically, like compiler will find the implicit value for you, or you can also pass the implicit value explicitly. So as you can see that here in the main definition, I have that initialize a implicit value discount that has a value 0.1. 0.1 is simply mean 10% discount. Okay. So when I call this apply discount method, it will simply take this implicit value discount, and this implicit value is automatically passing through the compiler. Compiler will do the all work for you. Here you don't have to pass it every time, like kind of default value. Okay. So this is the power of implicit, and this is the way you can use these implicit to overcome, increase the code readability and enhance the robustness of your code, right? So now let's talk about the type aliases. What are type aliases, and why we need these? So as we dive into the world of type level programming, let's explore the key concept that enhance our ability to express complex type relationship, right? So when we talk about the type relationship, we are talking about the hierarchy, right? Hierarchy, if I say, suppose you have a parent family member, and parent family member, and now you want to some child member that should extend this parent member. So this type of hierarchy can be explained by these type aliases. Okay. So type aliases will help you to declare your type. Suppose you want to create a variable name, create a type first name that can be of string. So type aliases allow us to create alternative names for existing types. They act as shortcut that make our code more readable and intuitive. And by giving these meaningful names to type, we can abstract away low-level details and emphasize the purpose of the type, right? Now, if I talk about the use cases, type aliases are particularly useful when dealing with intricate type hierarchies and relationship that I earlier told you, right? If you want to create child members that should extend a parent member, so we can use this type aliases so that we can create our own type by using the already predefined members of the Scala, right? Also, in our demo, I will explain the unit conversion using this type level programming. We will use the aliases like meter, centimeter, and to represent the different units, right? This simplifies our understanding of the type hierarchy, like how this meter and centimeter will come to the length family, length measurement family. So this will be the type aliases. Uh, and if I talk about it more, this not only enhances readability but also encapsulate the complexity of the type relationship. What if I more expand this encapsulation thing? Suppose you have a basket of fruits. You have banana in it, you have apple in it, you have mangoes in it. If you explain every entity as a separate, you will denote every member by their name. Now, if you want to simply create a certain class that should be dedicated by them, and that all the family members can come inside that, so we can call the fruit basket, right? So same thing we can talk about it here. And if you see this example, we have an object type analysis. Here I am simply denoting the type, and only I'm representing how you can define a type analysis and how you can use them and how you can increase the readability of your code. So suppose you define a first name with the type aliases variable and give the type of first name is a string. Same goes for the last name. Now, if you see the definition of the full name, it has parameter first name and the last name. Now, if you have to see only the full name and last name by the definition, by the definition of parameter, you can see that in the first name I have to provide the first name of my name, and in the last name I have to provide the last name of my name. It also increases the abstraction on because you only know that first name and last name is the type of string, right? So this way we can increase the abstraction, readability, simplification, clarity. Also, it helps to modify complex type relationship. The evolution of the code is very easy. You can simply change the child members or parent members if you want, and the major part of the code will not affect, right? So this is the type analysis. Now let's talk about the type bound again. So type bound is also an essential thing for the type level programming. And if I talk about the type bounds, this is the what I would say. Type bound is the only thing that we can define the constraint on the type parameters. We can like declare that this type should only be the subtype of another type or trait, and or it will be a super type. So we can declare it by using the type bounds. So if you see the definition of the type bound set limits on the type used with the type parameters, right? Or in other words, type bound restrict the types that can be used as parameter in generic construct. So if you guys see the example, we are enforces that A must be sorry, A must be subtype of animal. This variable we use. If you see that there are three type of type bounds: upper bound, lower bound, and unbounded bound. Majorly, you guys see this unbounded type bound. But apart from this, we have two other type bounds: upper bound and lower bound. So upper bound denotes the subtype, and lower type bound denotes the super type. We will discuss it further in the upcoming slides. So if you see this example, we can see that the pet store, if we are like in the upcoming code, if we want to initialize the object of pet store and we want to give the type of the pet store, the type of the pet store must be the subtype of animal. This constraint is defined simply satisfy this situation. If Suppose if there is a another like what I say, uh, suppose there is a class spoon that should extend the utensil class that can't be come under the animal class. And if I try to initialize the pet store object using that spoon class, I will not be able to do that. I will get the compile time error. The runtime error is far away. First, I will get the compile time error that I will be not allowed to declare a spoon class object because we have this constraint that the type should be the subtype of animal class. If there is a class that extends animal, then we can simply create the object for this, right? So this is the type bound. And the purpose of the type bound is solely that ensure the certain properties of behavior and type argument, which means we can apply the constraints on our types. Okay. Now let's talk about some the types of the upper bounds. Okay. So the first type of the type bound is upper type bound. Upper type bound, if I say an upper type bound specifies that a type parameter must be a subtype of particular type that I earlier told you, and this variable is used as a symbol for the upper type bound, right? If you want to say that this type must be the subtype of another class, trait, and xyz. Okay, so you have to use this sign. Okay, this symbolizes the upper type bound, which means T will be the subtype of comparable trait. Now, if you see the example more precisely, in we have a trait comparable that has a generic type T, and in the trait we have a method compare to. Now, what this is the trait. Now, if you see the definition of the get max method, we are constrainting that the T should be the subtype of comparable, which means every object of a class that we want to call that get max for it must be extended comparable trait, first of all. Another thing, the parameter of both is T and T, right? Which means we can only compare the same type of object, right? And in the last, the return type is also T, which means which means we are ensuring that the T must be comparable to itself. If I say that if I have a class of int, then int is only comparable to int, not to string, or not to string, not to double, not to float, no any other class. The int will only be comparable to itself, which is int. And so that's all. Yeah. And we bound that only some type of object can be compared. Yeah. So simple thing is we are bounding that only a same type of object will be comparable here in the getMax method. Okay. So this is upper type bound. So if you have to remember, the key point is upper bound means the subtype of other class. Okay. A will be the subtype of any other class. Now let's talk about the lower type bound. Now, what is lower type bound? And lower type bound specifies that the type parameter must be a supertype of a particular type. The previous one was the subtype, and this is the supertype. If you see the example here, if I see this line, B supertype A, it allows a wider range of types for the default parameter. If you see that the type of the default is B, which means the B should be the supertype of A, and A, what is it? A is the type of container, and container type, right? Container is a class that has a type of A. Now, if you see this example, whole example, the container, I have a object of container class which I am denoting by a string, right? I give the type string. Now I can simply create a object by giving this string into the type A. Now this A will be here, A will be here and here. Okay. Now I want to give B. Simply see that if you know that string is a subtype of any, and any is the superclass for other predefined classes. So int come under the any, string come under the any, float come under the any. So any is the super type for these predefined classes, right? So as you can see that here, I have a fallback variable that has a type any, and I give the value 42, right? I can give any value because the type is any. Now I want to call the container object to call the get content method. Now when I try to call the get content method, and in the value I am passing this default value which is fallback, and fallback is the type of any. Any is the super type of string. So as you can see that here, this line is satisfied by this thing. Now, if I remove the any from the fallback type and put it in the int, it will not compile. It will simply not compile. It will give you the compile time error, and it will not allow you to run this code or initialize this line. Okay, so this is the lower type bound. Any question till now? Guys, am I audible?
Yes, yes, you are audible to us.
Okay then. So the last one is unbounded type bounds. So as we can see that this is the most used type bound, which is when you say make this class generic, you will automatically thought about this unbounded type bound, because this a that has no restriction, we called it unbounded type bound. Okay, and if you see the example, we can see that here, box square bracket a value colon a, which it shows that the box and its type has no constraint, has no restriction. We can initialize the object of the class uh, whenever we want, and like anything, we can pass the string, we can pass the another class object, we can pass the int, we can pass anything in it. There is no restriction in it, right? So benefit for the this unbounded type bound is ideal for generic constant when specific constraint are unnecessary, maximize the flexibility in handling the various types. So obviously we can declare any object with it, so there will be very flexible, it will be very flexible. So I hope these important topics are clear till now. The implicits, the type bound, the type aliases, because it will going to be used in our demo project, demo. Okay, so let's go to the demo. Which demo should I do? It will be tough for you. Let's do this one. Yeah. So I hope my screen is still visible. Uh, so if you see that, I have a problem statement that says that implement a type level system for unit conversion. Unit conversion, what it is? If you the measurement unit I'm talking about here, the measurement unit, like you have to convert centimeter to millimeter, meter to centimeter. Same goes for the kilograms and grams. You have to convert the kilograms to grams, right? Now here we will talk about the hierarchy that I earlier told you, type aliases, type bounds, and implicits for obvious thing. Okay, so now let's talk about the requirements. So what can be the requirements for this? The first requirement, the you should define the measurement unit. So you for that you have to create a trait to represent different unit of measurement, like meter, centimeter, millimeter. These trait will be the serve as a marker for the unit type, right? Now implement type level conversion. Define a set of implicit method that establish conversion relationship between. Now if here I'm talking about the implicit method. Why? Because I don't want to call every time a dedicated method for the every conversion. I want I want compiler to do this for me, right? It should pick a dedicated for the conversion for my types, right? For my trait, for my class, for my object, to convert it from centimeter to millimeter or meter to centimeter, right? So here implicit plays the role. Now, type safe quantity representation. We are talking about the type level programming, so obvious thing, type safety will be there. So by the quantity representation, what we want to do, we want to simply initialize the quantity. how much we want to initialize a value for a particular type, right? 2 kilograms. So the value for the quantity will be 2 and the type will be the kilograms. Okay. If you see the example uses, you can see that here. The type of for the quantity is meter and the value is 5, which means 5 meter. And the variable name is length in meter. We are using 5 meters. Now I want to convert it into centimeter, right? Now I have a method convert which can be used as a global method. If I say, well, I'm not saying that correctly. Uh, just say that it's an abstract method for a convertible trait, and we will be override it according to our need. Like suppose I have to convert the length measurement, so I have to put the logic according to it. If I have to convert the kilograms and grams, I have to put the logic according to it. So it will be the logic for this convert method will be differed according to our need, right? Okay. So let's go to the code. I hope the problem statement is clear. Guys, am I audible or not?
Yes, you are audible.
Yes, yes, you are audible.
Any confusion till now? Anything you want to ask? Okay, cool. So let's go to the code. As you can see that here, I have a measurement trait that I will be used as a parent trait. It will be the super type for every trait, right? Now this trait is extended by the length and weight. By if you see the definition of this trait, length and measurement, you can see that the length will be extended the measurement, which means the length has some family members that we can use to measure a particular object length, right? Same goes for the weight, sorry. Now here we have meter and centimeter, which should be the family member of length trait, right, guys? Same goes for the kilograms and grams. That should be the member for the weight class, weight trait, sorry. Okay. Here, as the above, we have a quantity to measure the quantity. This is the case class. We are all using the case class. Here I'm using the variances of the class Scala. So this is not a type. Just remember that the whatever come in the type of quantity, it should be the subtype of measurement. This unit type denotes that, and this plus is denotes for the every other traits, right? I will try to cover these variances of the Scala in other another knowledge because it will be a huge topic within itself. Now we have a value for this quantity. So I hope the definition of the case class is understandable by you. Now, the main thing we have this convertible class. And if you see the type parameter for this, we have two. The first one is A that we want to use is convertible trait for, and the B we want to convert it into that class trait, right? So A will be our class that we want to use this convert method on it, and B will be the return type for it. Okay, we have the method convert. Now by this will if anyone want to tell what we uh, what is the sign of this, like what we call it.
Upper bounded.
Correct. Perfect. So what will be the A? How we define the A? Correct. A will be the subtype of measurement. Perfect. Now, as we can see that here, A will be the subtype of measurement and B will be the subtype of measurement. So here, what we want to say that convertible should be come under a parent class, which means the conversion should be done under the child of the measurement, correct? Which can be the length and weight. Now, again, here will be a confusion that this trait can be performed for the length and weight because both are the child of the measurement, right? But here is the catch. We will use the implicit for to remove this confusion. Now, I want to call this convert method to convert my value from meter to centimeter. As you can see that here, I declare this meter and centimeter in it, right? See. Just forgot about it. Now, as you can see that here, I have a convert method here, right? Convert method. Here I am again with, sorry, this quantity that it will try to get the method, sorry, the parameter of the this convert method is quantity. Here we are, I am using the polymorphism. This convert will be a separate method, and the this method will be this method, okay? Because we are calling using the variable, sorry, using the object of the convertible trait. Now, what was I saying? Yeah. As you can see that here in the line number 64, I created an object for length in meters. That was our goal, to convert a length in meter to centimeter without calling any explicit method or provided by the internally, right? So as you can see that here, I have declare a quantity which is in the meter and the value is 5, right? Now I want to convert it into centimeter. The centimeter, the rule will be clear, must be clear. The value should be multiply by 100, correct? Because 1 meter has 100 centimeter in it. So as you can see that here, I have an object convertible that have two implicits. First one is meter to centimeter and the another one is kilogram to gram. Now again, here I'm using the well. So that means it will compile only one time. Whenever I try to call that particular implicit meter to centimeter, it will again recall itself. It will not reinitialize its value. Am I clear? The initialization of the variable will be done only at the compilation time and will be done only one time. Okay. Now we have the implicits for convertible that has a trait that has a type meter to centimeter, and another one is kilogram to gram. So as you can see that here, when I try to call the convert method, which is this one, it will and put this length in centimeter as a parameter, which goes here as an object for the quantity of a, right? So what it will do, it will simply try to find out the implicit for it. If I show you the implicit for you guys, um, so implicits. See, as you can see that here, compiler automatically find out the implicit for this method, convert method, right? Because here I am passing a implicit for the conversion, correct? Now you guys are thinking, maybe thinking, I'm not sure, that why it's picking the kilogram to gram and why this picking the meter to centimeter. Anyone want to answer that?
As we have defined the type of the meter to centimeter in convertible trait like meter to centimeter, right?
Perfect.
Because of that, it is speaking the same implicit.
Perfect. So as you can see that here, this is the example of type safety in type level programming. What it I will do if I simply comment this implicit, as you can see that here, this method will this line will not compile. Why? Because it want to find the implicit for what trait, kilogram and gram, and you can see that here we don't have any implicit for this kind of trait, right or wrong? So if I want to convert only, if I want to convert kilogram to gram, I just have to declare this implicit and compiler do the rest job. It will simply pick the implicit for that particular method and will apply the logic on it, and you will have your value. This is the type level programming, guys. Now, if I talk about the readability of the code, sorry, that you can see that here by the reading of the code, you can simply find out which trait has which type, right? Which parameter has what type. This is the readability of the code. By using the type level programming, you can increase that. Now let's talk about the type safety. I can easily, I already showed you. If I remove the implicit for the kilogram to gram, it will show me the error. Compile time. Oh, the most important thing, it will not a runtime error. It will be a compile time error, right? There is a far more difference between runtime error and compile time error. Compile time error will help you to find out error early and will allow you to write the code very efficiently, right? Now let's talk about the enhancement of this code. Now, suppose you want to, what I can say that, now suppose you want to create another method, which what millimeter, right? So millimeter, maybe that should extend length. That should extend length. Now I want to write a conversion for this millimeter. What I have to do? What I have to do only, I just have to add another implicit for it. I don't have to do anything else, right? This is the enhancement of the code. Did I change the base, the boilerplate code? No. Did I change any other logic? No. I simply add my perspective of the code. Sorry, my main code to the existing code, and I have the output. Right, guys? So this is the introductory part of the type level programming. Though it's a very vast topic and very advanced topic. So there are many other component in it. But for now, this is the introductory part. Hope you get this thing. So any question, guys? Again, I'm audible.
Yes, yes, you are audible, and the demo was really great. Thank you.
Okay. So guys, that's all from my side. Now I'm open for any other question if you have. Otherwise, we can wrap this session and you can also contact me later if you found anything suspicious, if I say, or not understandable.
Hi, Yash. Thank you for delivering the session. And though it was very insightful and engaging,